does. So it describes spatial relationships means connectivity, relationship between the arc in the network, contiguity, relationships between the polygons. For example, with respect to line 1, left and right polygons are A and B. Then containment, this refers to what is within a polygon. Like within this, what is the polygon? So you, just give you an example, every line is bounded by 2 points. So for every line there are 2 adjacent areas, 1 and 2. Then every area is bounded by a closed cycle of lines. So this way. Then every point is surrounded by a closed cycle of lines and areas. So you can see this is the way. Yeah. And then line intersect only in points. So if I remove any of these nodes, it will give an error because you need to introduce the node if there is any intersection between the 2 lines. So if you see this, the first arc, the starting node is 1, ending node is 2. Similarly for 2, starting node is 4, ending node is 1. So this is why you take care of the connectivity. And if you see the entire polygon, the starting node, the arc first, it starts from D, end at C, what is on the left hand side C and what is on the right hand side A. Then second, start with D, end with B, and left hand side is A and then it is B. So that is the way you store your different topological model. I hope it is clear to all you that how the topological model is useful for vector data structure as well as how it is useful for developing any type of relationship. Now there are some of the differences between the spaghetti and the topological. Spaghetti is simple and easy to understand, more complex data structure. No spatial relationship retained. Here we are retaining the spatial relationships and can be performed largely without specifying coordinate data. And then lines between adjacent area must be stored and digitized twice in a spaghetti model. But in topological model, map updating requires reestablishing of topology. Now here I am showing you some of the old formats like DIME, dual independent map encoding, Tiger, topologically integrated. They are very conventional models which was adopted, I should say, in 70s or 80s, start 80s. And then you have DLG, digital line graph. But if you see a present file format, that is a shape file which is called to be an OGC compliant format. Why I say OGC or an open format? Because the data structure of this particular format is open to all. So if somebody wants to, like for the interoperability case, you can use a shapefile because even if you go to a internet or a website, you can easily explore the data, the structure of a shapefile. So that's why it is called as an OGC compliant format. Then the third, the last one is the present is a geodatabases, wherein we have it is a next generation database wherein you have different type of like person geodatabase is there, and we have recently introduced a file geodatabase, like it is being introduced by ESRI, and then the third one is the enterprise geodatabase. So there are different type of, and it has got lot of advantages over a conventional model like shapefile or ArcInfo coverage. So it is a new generation database. So like just to tell you some detail on the shapefile, it has got different different type of files associated with a shapefile. So it is a native GIS structure for a vector layer. It's not a fully topological, limited information about the relationship of feature of one to another. It draws faster. It has got SHP, SHX, DBF, and SBN. There are different type of files which is stored if you store a shape file. SHP means it will have on shape. SHX means it is used for performance. DBF means it will have all the attribute information available. SBN and SBX are used for indexing. Indexing means how you can retrieve the data much faster. So indexing is meant for performance, how you can retrieve a data more faster. And then it is openly published specifications so that other vendors can develop shapefile and read them. So it is a OGC compliant format. So what are the advantages of a vector data structure? Good modeling of objects. It is having a compact data structure. Topology can be described explicitly, therefore good for analysis. Coordinate transformation and rubber sheeting is easy. and then accurate graphic representation at all scales, and retrieve, update, and generalization of graphics and attributes are possible. So it has got a lot of advantages compared to a raster model. And then the disadvantages is it is a complex data structure. Combining several polygon networks by intersection and overlay is difficult, and display and plotting often time consuming. So there are, because of the complex data structure and because of the several networks intersection, because you are dealing with n number of coordinate pairs, that's why these operations are slightly difficult. So now we talk about the raster data concept. As you already know that raster is vaster but is faster. Raster is vaster means you have a raster data and you have so many pixels of a particular area. That's why it is called as a vaster, but it is faster. Faster means you can do the processing very fast because the data structure is very simple. So here the attributes are recorded by assigning each cell a single value based on their majority at feature in the cell. So you have different type of different bit structures, 8 bit, 6 bit, 7 bit. So you can have a square grid, equal length grid, you can have a rectangular grid, you can have a triangular, hexagonal, triangle. Now if you see this triangular, this is the example of irregular tessellation, wherein you have so many triangles with different sizes. And similarly you will have a square grid which have equal length. You can have a 4 connected neighborhood, you can have 8 connected neighborhood, you can do different type of analysis to these particular type of this thing. And then coming to the raster based data structure to effectively increase data processing performance and reduce the demand for data structure. Now here we are more concerned about the data storage because the file size of a raster is very big. Now because of that big file structure, it is very difficult to use this data for because it consumes most of the your file disk. So that's why you need to come up with certain methods to compress this data. Then this is the compression method, how to more efficiently store the data. And second thing is the scan order, how you can scan the data in an array and deals with performance in terms of data process, means how you retrieve the data. So in a raster data there are various ways you can retrieve a data, so that is also you can do. So one example is a run length encoding. This is also used for the data compression. Now if you see this this particular raster grid, you have ninth this is column and this is row. If you see the row, ninth row you have now 2 to 3. 2 3 means your data is here 2 and 3. So it starts from 2 and ends with 3. This is one coordinate pair. The one pair, then another is 6 6, that is you start with 6 and you end with 6. Then in 8 10, that is you start with 8 and end with 10. Had it been 12, you could have stored in a one pair